Okay, so the area of the base is pretty straightforward. It's just of the square base, which is just 400. So the area of the base, and I'll do it a little square there, is 440 squared. Okay, and now the area of the triangle part, that's going to be a little bit trickier. So the area of the triangle is going to, and I'm going to put a 4 there because I'm going to multiply that by 4, is going to be, again, be careful here because we have the base. Well, the base is pretty easy. That's 440. That's this base here. All the bases are 440. So we need base times the height divided by 2. So base times the height. Now the height is this here, and this is where you can confuse things a little bit. That's what that represents. This black line here is really this black line over here. If you look at that triangle from the side, or this one here, or that one there. Now again, keep in mind that's that angle right there. So to get that height, we have to use Pythagoras, and we're going to, again, we have the height here, which is 147, and we have this half of this is 220, so it's going to be 147 squared plus 220 squared equals that height, or we'll call it S for slant height squared. Okay, so let me get my calculator out. So 147 squared plus 220 squared, and then take the square root of that in order to get the answer. So 264.6. So 264.6 is the height times that by 440 to get 440. And now I need to divide that by 2 to get the area of the triangle. And finally multiply that by 4 to get all 4 triangles, and then I'm going to add that to 440 squared, which is going to be a large number here. So that's a huge surface. Well, obviously the pyramid is huge, and we're measuring this in meters here. So the final answer is going to be, the surface area is going to be, what is that, 426,000. So very 426, and I'll just round it up like this, 1,000 meters squared. Wow. Okay, so it's huge. I don't know if anybody's been there, but that's incredible. Okay, so now we have let's do an example with the cone here. Cone-shaped container has a height of 15 centimeters and the base of, so let's draw a diagram here. Cone-shaped container has a height of 15, so let me do my best cone here. Okay, it has a height of, be careful when they say height and not the slant height, so that's 15 centimeters, and the base has a diameter of 16 centimeters. Determine the volume and the surface area. Okay, well, the volume is going to be 1/3 again of the area of the base, which is pi r squared times the height. Pi r squared is going to be pi r is going to be 8 pi r squared, and then times the height, which is 15. So that's the volume. You can do that on a calculator. Surface area, again, this is the one you just have to you know, take my word for it, take their word for it here. Surface area is pi r squared, which is a circle on the bottom, and pi rs. So pi r squared plus pi rs. Now the hard part here is going to be getting the s, and the s is this thing in green here. Okay, that again, now we have to use Pythagoras, and what I really have is this triangle here, which I can use Pythagoras to solve for that. So 15 squared plus 8 squared gives me the slant height squared. So 225 225 plus 64, and then the square root of that is 17. I should memorize that one. So the slant height is 17. Everything else is pretty straightforward, and you can do that on your own. Okay, so again, the key thing here is just using Pythagoras. You see Pythagoras comes up all the time, and you do have to know it quite well. Okay, I'm not going to do this next one, but I will sort of give you a hint at how to do it. Okay, so now we're basically doing the same thing, except the base is a hexagon, so something like this up here, hexagon with 6 sides here. So to get this area here, you will have to break this thing up into some sort of familiar shapes to get that area. You might do triangles like this. Okay, or you can do maybe you can do a like a trapezoid, 2 trapezoids. Okay, you can do 2 trapezoids, or you can do you can maybe start cutting it up into bigger triangles or squares, again depending on what you're most comfortable with. But again, that's kind of how we do those. All right, so let me just jump on to the next lesson where we're going to do the spheres. Okay, so looking at the surface area and volume of spheres, we're going to quickly see that I'll start with the volume here. The volume is here's the equation: 4/3 pi r cubed. Now, it's not that difficult to understand how to get this formula. It does have something to do with the cylinder, okay? Because if you look at a cylinder, I'll just go to this diagram up here. A cylinder is, you can put a sphere inside of a cylinder, and you can have some things that are similar. For example, the radius here would be the same radius of the cylinder. So there are some commonalities there, and you'll see that it's not that difficult to understand how to get the volume of the sphere. And just again, read through this, and you should be clear on that. I'm not going to go through that, because really what you need to know is how to use the formula. But if you are curious of, if you do want to understand this a little bit better, it is kind of interesting to see how they get it, because it does relate to the cylinder. Okay, the surface area of the sphere, on the other hand, is a little trickier. It's 4 pi r squared, and really that one goes beyond this course. You do need calculus to solve, to prove at least, how to get the surface area of a sphere, because really there's no way to draw a net diagram for a sphere. It's really tricky. All right, but you have your equations are pretty straightforward. They're not difficult, and you can use them pretty straightforward. Now, the surface area of a hemisphere, is really just half of the sphere, and the volume is pretty straightforward. It's just half. Okay, the volume of a hemisphere is 1/2 of the sphere. The surface area, well, it's half of the curved surface, so half of this, and then you got to add the circle part. Okay, like they do over here. So it's the circle part and then the spherical part. All right. And again, the circle part is just pi r squared, which we know here. Okay, so you can go ahead and fill all these out. Let me just do a couple examples. So the shape of the planet Pluto is approximately that of a sphere with a diameter of about 2,300 kilometers. Okay, I'm going to do a diagram in the middle here. Let me pull this up a little bit. All right, there's my sphere. Hopefully you can maybe imagine that sort of three-dimensional there. I'm not sure if that helps. Not the best artist here, but bear with me. So the diameter is 2,300. So the radius here would be 1,151 kilometers. Not a very big planet. Okay, so again, what the surface area? Well, the surface area, again, just jump back to your equation here. The surface area would be 4 pi r squared. So surface area of a sphere there would be 4 pi r squared, and then that's pretty straightforward. You just plug the numbers in. The volume as well would be the volume of my sphere there would be, again, it's 4/3 pi r cubed. Okay, so you're given these equations on the test, 4/3 pi r cubed, so you won't have to memorize any of these. Okay, so that's pretty straightforward, just plugging the numbers in. All right, so again, I'm gonna stop right there. Some questions might ask you to work backwards. You're given the volume and you have to get the radius, but just solve for the radius and you'll be fine. Anyway, we'll practice a lot of these in class over the next couple of days. But again, if you do want to develop more of an understanding of how they get these formulas, where they come from, just follow this, read this section through and follow the steps, and you'll easily see why the volume is 2/3 or 4/3 pi r cubed there. It's actually 2/3, and then they multiply it and the extra 2 because the height is 2 times the radius. Anyway, thanks guys for watching, and we'll see you in class. Hi everybody, today we're going to do lesson 8 and 9 of our measurement unit. We're going to look at surface area and volume of pyramids, cones, and spheres. Okay, so we're going to start off with right pyramid, which is a pyramid whose center is right above the middle of the base. That's really important, so it's not slanted. Each of the sides are going to be in the shape of triangles. Okay, so that's also really important. All right, so let's jump into the volume of a right pyramid. If you read through this little section here, you're going to find out that it takes 3 pyramids to fill a cube or a rectangular prism. In other words, if you were to fill this pyramid here with water and then dump it into this cube, again, the key thing is that the height of the the cube has to be the same height of the pyramid. You'll find out that it takes 3 pyramids to fill a cube. So therefore, the volume of a pyramid is going to be 1/3 of the volume of the cube. So now let's look at some cones. It's very similar for right cones. Again, right cones have their center or their apex, I should say, right above the center of the base. That's important. They're not crooked. We have here the slant height, and then the actual height from the bottom, and then the radius. Again, note here that this is a right degree angle, and many questions are going to ask you to find the slant height or the height, and you're going to have to use Pythagoras here to do that. Now, very similar to the pyramid, it takes 3 cones to fill a cylinder, which has the same height as the cone. So again, volume of a cylinder is 3 times the volume of a cone. Okay, now let's look at some surface area. Okay, surface area is a little bit trickier. Okay, we have for the pyramid. Well, for the pyramid, it's not tricky because it's just the area of the base plus all the triangular sides. So if we go here, we're going to add up the square base. It doesn't have to be a square base, but basically it's the area of the base plus the area of each of the 4 sides. Or again, it doesn't have to be 4 sides, but the key thing is the sides are all triangles, so we can easily find the area of the triangles and then add them all together. Okay, the surface area of the cone, on the other hand, is much more difficult to prove, and actually, I mean, clearly, if you cut this cone up, it's gonna be some funny shape that really has curved edges, and we're not going to be able to kind of determine the formula ourselves. So that's why it's given to us here. Again, the pi r squared. Well, that's just the area of the base, which is a circle. But then the area of the vertical part of the curved surface is pi rs. So it's pi times the radius times the slant. And you'll notice this little this note here. You need to know calculus if you're going to prove that. Okay, so all you need to do is just plug numbers into the formula. All right, the volume or the surface area of the pyramid. Again, we talked about that. So the volume of each one is pretty straightforward. It's just 1/3 of the cube for the pyramid and 1/3 of the cylinder for the cone. Okay, let's do some of these questions. So we have the Great Pyramid of Giza is constructed to be one of the 7 wonders of the ancient world. It is approximately 147 meters tall. Again, try to do a diagram. These diagrams can get a little tricky here. You know, try and do your best to do a diagram. There we go. So it has the height of 147. That means that is 147 there, 147 meters, and has a square base with the sides measuring 440 meters. That thing's massive. Wow. Okay, so 440 meters. So make a sketch of the pyramid and calculate the volume to the nearest cubic meter. So again, it's going to be, the volume is going to be, well, first of all, pretend this is a cube, and then just take 1/3 of it. So the volume is going to be 1/3, and then it's going to be base, or the width times the length here. So 400 times 400, 440 times 440 times the height, which is 147. So that's going to be the volume. Make a sketch of the net of the pyramid. A net diagram is a diagram where you take the 3-dimensional shape and you make it into a 2-dimensional shape. So if I were to open this up, it would look like this. This way, it's just a little bit easier to calculate the surface area, because I just have to add up 1, 2, 3, 4, and 5 of those shapes, which